All right, we are ready to go here. So, welcome everybody to our monthly Ask an Expert session. This month featuring a topic we've done a couple of times before, but always new users and people who just want to learn more. SignalTap. So, my name is Steven Strell. I've been with Altera and then Intel now for 18 years. I've been in the training group for 16 of those years. If you have attended a training class or listened to one of our e-learnings, chances are you've probably heard my voice at one point or another because I've done a lot of them. I cover lots of different topics, but these days I focus mostly on power, external memory interfaces, platform designer, our system design tool, block-based design, and of course debugging with SignalTap. And my email address is listed right there. There will be other links that get posted in the chat, so keep your eye on the chat as we go through. But before we get started with the actual session, Marlon, can you explain how people can get their questions in?
Yes, so welcome everyone. My name is Marlon Price and I'm a moderator. I'm also a trainer as well for Intel. So basically what Steve just showed, we're colleagues, we've been colleagues for a long time. I do the same. So if you have questions, you can do unmute yourself like it shows and ask it over the audio. That's perfectly fine. You can also ask by chat, which what a lot of people will do. Just enter it in the chat and I will be moderating those and relaying it to Steve.
Great, thank you, Marlon. So the ground rules for our Ask an Expert sessions. So any question you can think of about SignalTap debugging is fair game. Please feel free to just lay it on me over the phone or in the chat. If it's a very detailed design specific question, I'll try to answer it if I can based on what you say. Of course, without seeing your design, it's going to be more difficult, but I'll provide whatever suggestions I can. And hopefully I can answer in a reasonable amount of time during the session. If not, we'll try to follow up with you after. We may ask you to put some information in the chat or send an email or something so we can get in touch with you after the session if you need further assistance. Because the goal is I want to get in as many questions from as many people as I can. And if I can't help you and you need further assistance, then I may point you to your local FAE. So, all right. So why are you here at our session? Well, maybe you have never used SignalTap before. You don't know what it is, what it does, and you might be in the same boat as other folks who are attending. I've heard about SignalTap and tried to use it, but I just don't get it. There is a lot of options, a lot of different things in the tool. When I'm not getting questions, I'm going to, demo some stuff. I'm going to talk about some new features and things. So just get a brief overview to show you what's in there and hopefully guide you to help you out and get more information. I have extensive experience with SignalTap and it works great, but what are some of the new features? Like I said, I'm going to show you some of the new features that came out in the past couple of years. I have to recompile just to change a trigger setting. So one of the biggest complaints I hear when I'm teaching folks about SignalTap is having to compile or recompile your design because it basically becomes part of your FPGA design. And so I will talk about some ways to help mitigate that a bit. You're just stuck. It's our tools are complicated. There's a lot going on, and I want to be able to help people so that they can help themselves really and be able to debug their designs easily because SignalTap just has so many great features and that I use all the time. And you still call it SignalTap 2. We dropped the 2 a long time ago. Some people still call it SignalTap. There's also an official space now between Signal and Tap. So just FYI. So Marlon, any initial questions come in before I just dive into some stuff?
No, nothing yet. So just go ahead and I'll check the questions that came in offline, but go ahead and continue.
Okay. Yeah, again, please feel free to start getting your questions in at any time, and Marlon will interrupt me and I will address your questions immediately. So one of the things that I just want to highlight real quick is where you can get more information. It's not immediately obvious from the Intel website where to go for information about SignalTap or anything else FPGA related. So I recommend going to the Developers tab at the top and then going to Resources and Documentation and the Learn section. And in there, under Resource and Documentation, of course, that's where all our documentation is. And if you scroll down a little bit, there's a Featured Resources section, and that's where all the Intel FPGA and Quartus stuff is located. And then if you go to the Learn section, you scroll down a little bit and you get to the jumping point to our training site. So if you want to look at all the courses that we have available, see what classes are coming up. If you're an absolute beginner and you want to learn what an FPGA is, we have a link directly to an FPGA architecture training here. All easy to access just from that Learn option from the top tab on intel.com.
Steve?
Yes.
This is a good point for one of the questions came in before.
Yes.
Does SignalTap support all devices?
Does SignalTap support all devices?
All devices.
SignalTap supports all devices that include on-chip memory blocks. So that is basically Max 10 on up are supported by SignalTap. I think even the old Max 5 supported it. I don't remember, but basically yes. The short answer is yes. Every device supports SignalTap. So there you go. Okay. As other resources, so as I mentioned, Marlon's going to put resources in the chat just so you don't have to, go searching for them. But I just wanted to highlight a few things. So we do have a full day instructor-led training on SignalTap. Incidentally, I'm teaching this class tomorrow, so you can certainly still register if you want to. That is going to go over the whole flow of creating a SignalTap file and configuring it and adding it to your project. And there's a hands-on lab exercise section, so you will get to work with the software and the hardware. Actually, you'll be connecting to a remote development kit and be able to run the design in hardware and see a problem in a design and debug it. So lots of opportunity for learning more about SignalTap. I also have a ton of additional e-learning available for it. I have a whole series from start to finish about using SignalTap that was actually just recently updated. So it's got some good stuff there that you can check out. And then, of course, documentation. So the debug tools user guides are the way to go. Both there's a version for standard and there's a version for pro. And then finally, videos. So I mentioned before that this session is going to be recorded and will be put on the Intel FPGA YouTube channel. So you can go directly to videos or directly to playlists. We have a number of useful playlists. We have a playlist that we just recently started of all of these Ask an Expert series sessions. So you can check out any of the ones that we've done previously. And also we have our short engineer to engineer training videos, as well as longer training videos that are similar to what we have available through our course catalog. So lots and lots of resources available for you to continue and learn about SignalTap and other aspects of FPGA design available from Intel. All right, so before I get into the newest SignalTap features, Marlon, are there any questions that have come up? Marlon?
Yeah, I'm looking to see. Okay. No, nothing's coming yet. Just go ahead and continue. I'll pop some of the
all right
ones I've received.
Sounds good. All right, so I already have a project open. I just want to go over a little bit about what SignalTap is for maybe those folks who are not entirely familiar with it, but it's an embedded logic analyzer. It's the idea of being able to monitor signals, embedded signals in your design while the design is actually running in hardware. And the way it does that is that you select the signals that you want to monitor, in this example, I am looking at, let's go over to this instance here. I am looking at some signals that go out of my design to a 7-segment display on my board. I want to be able to check those signals and make sure that I'm getting the correct outputs. So we call this tapping signals. And you tap signals by simply double-clicking in the node list here, and that opens up the node finder. And this allows you to search your design for the signals that you want to tap. Now, when we talk about tapping signals, we're talking about, there's 2 uses for tapping signals. Signals that you want to monitor, so you want to see what their signal levels are while the design is running, and signals that you want to use to build up trigger conditions. So the trigger conditions, the trigger is what tells the logic analyzer to stop and capture data, so you can see what the signals are doing around that point in time. And so in the node finder, we can easily search for different types of signals in the design. And if you're familiar with the FPGA compilation flow, you know that there's 2 stages of compilation. There's synthesis, where your design is actually turned into logic primitives. And then there's place and route, where those primitives are actually physically placed, located in the device and wired together. And when you're working with signal tap, because it becomes part of the design itself, you can choose which types of signals you want to tap. So there's different filters here that let you choose what signals you want to tap. So I often use signal tap pre-synthesis. Pre-synthesis signals refer to signals that are directly in my HDL code. They are original design signals that I want to look at, connect to, and see what they're doing, just the way that I coded them. And by tapping them as pre-synthesis like this, then those connections exist throughout the full compilation process, and then I can monitor them very easily. Now, there's also a few other filters I want to highlight here. The second one, post-fitting. So post-fitting filter allows you to select signals that exist after the design is fully compiled, after it's been placed and routed. The idea being that you don't want to touch your finished design. You already got your design is finished, you compiled it, and you just want to add signal tap after the fact, essentially.
Steve?
So you want to look at post-fitting signals for tapping. Yes, Marlon, question?
Since you're talking about this, rapid recompile, can you talk about the effect of rapid recompile? Someone asked about what's required to use rapid recompile.
Okay. Is it specified standard or pro in that question, or just rapid recompile in general?
Yeah, just rapid recompile in general. Does not specify.
Okay. All right. So that actually ties really, like you said, directly to what we're talking about here. So the signal tap post-fitting filter is going to tap and connect to signals in the post-fit netlist, meaning that it's going to not touch your design. It's going to look for available wires, available routing channels, and connect to those signals after the design is fully compiled to have minimal effect on the design itself.
And he mentioned pro, just so you know.
Oh, okay. Well, all right. Yeah, it's a little different between the two, actually. So, yeah, I actually have slides on that for Pro. So, but the idea of rapid recompile is, in either standard or Pro, is that if you were to change certain aspects of the design, maybe you wanted to tap additional signals here, maybe you wanted to adjust the trigger conditions in some way, okay? The problem is, like I mentioned at the beginning, is that when you make changes to the logic analyzer, you have to recompile, and that's a pain. And so the idea of rapid recompile is just that, to recompile as quickly as possible with minimal effect on your actual design and get signal tap into a state so that it will work with the changes that you have made. Okay, so in both standard and pro edition, we do have options for rapid recompile. I'll just very briefly in what it is in the standard edition. In the standard edition, it's the idea of node allocation. Basically, you before you compile the design, you basically give SignalTap additional resources ahead of time, okay? So what do I mean by that? Well, you'll notice here that I have tapped 7 signals in this design. And over here in the signal configuration section, under nodes allocated, under data, this is set to auto. Now what that means is that when the logic analyzer is compiled, it's going to use just enough device resources to implement the SignalTap logic analyzer as it is to connect to these 7 signals. But what if in the future, maybe I want to tap additional signals? Normally, I would have to add those signals and then recompile the whole thing with a long recompilation. But what you can do with standard edition rapid recompile is you switch from auto to manual over here, and you'll notice that by default, the manual field is set to 7 because that's the number of signals that I have already tapped in here. What I could do is bump this up to, I don't know, 16. And what that means now is that after I compile the design, I could add up to an additional 9 signals without having to do a full recompilation of the design. All I would have to do is perform this special rapid recompile. So unfortunately, the buttons are not very useful. I don't like them. This does a full recompilation, so you don't want to accidentally click that. This does a rapid recompile in standard, okay? Now, the Pro Edition does allow you to do this resource allocation, just like standard, but Pro has some additional features for this as well. So I actually have a couple of slides on this. In the Pro Edition, Rapid Recompile builds on what I just discussed with Rapid Recompile in the Standard Edition by allowing you to make more changes and have a fast recompilation with them than just node allocation, okay? In the Pro Edition, it performs an ECO, a special ECO compilation. So ECO stands for Engineering Change Order, and that's making small, minor changes to the design and then just recompiling the post-fit netlist just enough to implement those changes without affecting the main design itself. So in the Pro Edition, you can make additional changes to the design and still get the advantage of a fast ECO compilation. So you can change things like whether a signal is used for data or for building up triggers, also for adding to additional triggers. You can add additional post-fit nodes to the node list, which is what you could do in standard as well. You can switch back and forth essentially between the pre-synthesis and post-fit versions of a signal node. Now, why would you want to do this? Well, sometimes you might not have a signal available to you post-fit. Maybe it got optimized away. There is a feature that I also have listed here about preserving for debug to prevent that from happening. But let's say, there's a signal that you want to look at, but it's gone in the post-fit netlist. You could, if you had previously tapped it and it got optimized away for some reason, you could switch back over to the pre-synthesis version of it, and so that you'd still be able to access that signal, and it would still be part of the ECO compilation, so it would be much faster to include in your design and be able to do a rapid recompile. So it's pretty advantageous to be able to make these types of changes after you've already compiled the design and then just run a special ECO compilation. Another advantage of this feature is that it checks the changes that you've made before recompiling. With the standard edition, it's kind of a gamble. You make those changes and then you do the rapid recompile, and it may or may not be able to preserve resources and implement the design. Whereas in the Pro Edition, you get a dialog box I'll show you in a moment that lets you know if the changes you've made support this feature, okay? And as I mentioned, this benefits from having preserved debug nodes to allow you to be able to switch back and forth between the pre-synthesis or post-fit versions.
I have another question before once you've done with your explanation here. Once you
Okay.
go ahead and finish your explanation.
Should I keep going, or should I?
You just finish your explanation and I'll ask
Okay.
the question.
Okay. Yeah. So just to illustrate what this rapid recompile feature in Pro does, normally without this feature, you'd have to do a base compile of your overall design, which could take a period of time. And then, you would, you discover there's something wrong with the design and you add signal tap, and then you have to recompile the whole thing all over again. And then anytime you make a change, you'd have to recompile. So this can take a lot of time. But the idea behind Rapid Recompile in the Pro Edition is that what you could do is start when you create your design in Quartus, you include essentially an empty signal tap. You haven't tapped anything yet. Okay. So but then instead of having to add signal tap later on, signal tap is already there, and you add these nodes and then perform a short ECO compilation. And then you can continue to do that, and so that your debug iterations are going to be much, much shorter. Okay. The ECO compile is a huge time saving because it's not touching your post-fit design. It is doing post-fit using post-fit routing that is available, and just making changes as needed. So it's very smart about reducing the overall compile time.
So real quickly, ECO, yes. A question came in. ECO is not supported for ARIA 10. So does that mean we cannot modify post-fit nodes with the ECO compilation with ARIA 10?
ECO is not supported on ARIA 10? I think I need more detail on that. ECO is supported on ARIA 10, and ARIA 10 can be used in both standard and Pro Edition. It's the single device family that does work in standard and Pro. You'd obviously have to be designing for ARIA 10 in Pro for this feature to be available. They provide more detail on that, Marlon? I never heard that there's no ECO for. I never heard of that.
Sorry, the question came from me.
Yes.
This is Yilin, and
hi.
And yeah, we have discussed this with our FAE, and it's agreed upon that ECO flow is not supported for ARIA 10 on Quartus Pro. I can paste the link to the Intel web on this.
No, that's okay. I hadn't heard that, but I don't know if that's true. I don't know if that's even associated with this. I have not heard that limitation at all, and I've been using this feature for the past 2 years, so that's news to me if that's the case. Marlon, have you heard of that at all?
No, but the ECO flow, like the tool that you use. Yeah, I don't know if they distinguish between that and signal tap would be the question. Yeah, we'll take that. We'll take that up.
We'll take it offline. This ECO flow is different from the I'm doing finger quotes, the ECO flow that you normally would use. So yeah, I had not heard that about ARIA 10, and I can check on that, but had not heard that. So thank you for pointing that out. So
thanks for following up.
Sure. Yeah, we'll check it out. Any other questions, Marlon, before I continue?
No, that's all so far.
Okay. So this screenshot shows you basically what you can change, what is a valid change in the Pro Edition that will work with this ECO recompilation feature. So you can switch your different between basic and basic or trigger types. So the trigger type that you select for a trigger condition column is what determines how the trigger will be analyzed while the design is running. Usually you use just basic and. So all of the signals in the column need to be the particular condition that you specify. They need to be high, they need to be low, it needs to be a rising edge, a falling edge, etc. But also we have a basic, question, Marlon?
Quick question. Could you explain exactly what is an empty signal tap?
An empty signal tap?
You brought that up in the last one, in the diagram, the chart about, doing that initial compile with an empty signal tap. Could you just explain a little bit more what that is?
Sure. Yeah, I didn't explain that. Yeah, that's just creating an STP file and making it part of the design, and then basically not doing anything with it. So you haven't added any nodes to it. Maybe you specify the sampling clock you'll use because you have to specify the sampling clock, but it could just have no nodes in it. It could just be empty. And then later on, you can decide after you've compiled and you found an issue, you add the signals that you want to analyze in the node list here. and then perform an ECO recompile. So that's what I mean by an empty signal tap.
It might be good to point out about the lock mode, because maybe some don't understand that how certain changes can be made with signal tap dynamically
Yes.
without compiling.
Yes, that's a good point. Yeah, I will get to that in a second. I just want to cover
Okay.
the other changes here, but that's a
Sure,
very,
sure.
very good point. Yeah, so you can switch between basic and or basic or, which is something that you could not do without a full recompilation previously, because it basically changes the logic structure of the logic analyzer, but now that is a supported change with an ECO recompile. There's this extra tap column in the Pro Edition that indicates whether a node is pre-synthesis or post-fit, which is also indicated by the color here of the nodes. Black is pre-synthesis, blue is post-fit. But you can click these to switch back and forth between pre-synthesis or post-fit if you want to. You can add additional post-fit nodes. And it also, like I said, works with the node's allocated feature to allocate additional device resources. You don't always have to do this in Pro. It might be a good idea to do it, but you might still be able to get away with the ECO recompile depending on the design without allocating the additional resources. Allocating additional resources, though, is always a good idea. So what Marlon was talking about is the lock modes up above here. So I don't think let's see, I can show it in the demo. Maybe it's easier to highlight here. Yes. So there's in the Pro Edition, we've got 2 lock modes: allow all changes, of course, and allow trigger condition changes only. And what that option does is it prevents you from accidentally making a change that would require you to recompile your design. So you'll notice that it grayed out certain things here. Most of the options here are all grayed out, so I can't accidentally make a change that would require me to recompile. And so that's always a good safeguard. If your design is finished and you want to do an ECO compile, you can, or you don't want to even do an ECO compile, you can just lock out the changes that would that you cannot do with fully recompiling the logic analyzer. So, but for our purposes here, we're assuming that you can still make some changes. You're going to maybe add some additional post-fit nodes to your design. And then when you click that Start Rapid Recompile button, it brings up this very handy dialog box, which the standard edition unfortunately does not do, but it checks all of the changes that you've made since you last since you last compiled the design, and it indicates whether the changes that you've made are supported for an ECO recompile. Okay, so I changed the number of nodes I've allocated. I added some additional post-fit nodes, and all of those types of changes were supported. Okay. However, in this example over here, I changed some pre-synthesis signals that I didn't preserve, and so it shows me immediately that those changes were not supported. Tapping a pre-synthesis node here, not supported because I would need to fully recompile the design. So the dialog is nice because if you see something here, you can then back out of the changes that you made. Unfortunately, there's no button to do that. You'd have to back out the changes manually. But once you get supported for the status for all of these changes, you just hit recompile and it does this short ECO recompilation. So that was a long explanation, but there's a lot to that feature. So I hope
Good
whoever asked
explanation
that.
still.
Yeah, I hope whoever asked that question got their money's worth for that one. So, which was nothing because it's free. So, any other questions right now, Marlon?
Yes, so since we're done with the rapid recompile, can you talk about the storage qualifiers?
Storage qualifiers, sure. Okay, so going back to the tool here, and I'm going to unlock it. Storage qualifiers. So where are we here? Yes, up here. Oh, because I disabled it. Oh, wait, no. Why is that grayed out? I don't know why it's grayed out. This is disappointing right now.
on the right
Okay,
instance.
Am I missing something?
Instance
That
var,
one.
instance, yeah, just use instance 10.
Oh yeah, all right. Yeah, I didn't enable it in instance 1. That's why it's turned off. Thank you. Yeah, it's grayed out because I never added it and I recompiled. So anyway, so storage qualifiers. So storage qualifiers is a feature that I had actually requested for years, based off of what you can do with a bench logic analyzer. In a bench logic analyzer, even though you can have gigabytes of storage space to store captured samples, there's going to be periods of time where a signal is just staying at 1 or staying at 0, and you don't really care about what's happening in the design at that point in time. The storage qualifier allows you to essentially drop those samples that you're not interested in and only focus on capturing in the buffer space the samples that you are interested in. And in an FPGA especially, you've got much more limited buffer space, limited by the on-chip memory. So storage qualification is an easy way of making sure that you see just the data that you need to see for your debugging process. And there are a number of different storage qualifiers. So by default, this is set to continuous. But you could choose input port, which is like a write enable. You choose an additional signal that when that signal is active, and the trigger occurs, then data is stored in the buffer. If that signal is not active, then any samples where it is not active, those signals, that captured data is dropped. We got transitional, so you could pick a signal, and whenever the signal transitions from high to low or low to high, you can choose that you want to capture that. So that's if you're watching a signal and you don't want to capture data where the signal is just stuck high or stuck low for a period of time. Conditional allows you to create an additional condition, actually. So it adds another column here, so you can add create a new condition. It's not a trigger condition, it's a storage qualifier condition. So when that condition is true, data gets stored in the buffer. And again, all of this happens around when the trigger occurs. So everything is still based off of the trigger, but you qualify what samples get stored in the buffer around when the trigger occurs, before or after, depending on whether you're looking at pre or post trigger data. There's also start stop, so you can specify 2 conditions, when to start capturing data and when to stop capturing data. And there's also state-based trigger, and that's used if you're using the state-based triggering option, which is being able to build a full state machine to define your trigger conditions and when they get checked and everything else. So when you choose a storage qualifier, you have a number of additional options. For the transitional one, which is what I had in here initially, I can choose, so what I've done here, they're all turned on. So what that means is I'm only going to capture data samples when any of these signals are transitioning from low to high or high to low. Okay, if the signal is held high or low for more than one cycle, then that sample is going to get dropped. Okay, so if they're all high or all low or all fixed high or low, then those samples are going to get dropped. And that way I only see when there is data transfer, and I don't have that right now in the data. There's also a nodes allocated option for this, so you can reserve additional resources for your storage qualifier. And then the 2 options down here, record data discontinuities. What this does is that in the captured data, it will show you where there are gaps in the data, where samples have been dropped. Now, once a sample is dropped, there's no way of seeing what that sample was or how many samples were dropped, but you'll know that there is some time difference between the previous before the discontinuity and after the discontinuity. And then finally, disable storage qualifier. This is and both of these are runtime options, meaning you can change them without recompiling the design. So if I am not seeing the data that I want, maybe because the storage qualifier is filtering it out, I can temporarily disable my storage qualifier and see all the data again. Okay. So that is storage qualification. Was there any more to that question?
No, that was it. We're just asking how they worked.
Okay.
Use that a lot. Another one, could you also, what is a power-up trigger, and what do you do with it?
Power-up triggers. Okay. So a power-up trigger, one of the things about the logic analyzer. It's a great tool, but when we're working with an FPGA, you have to first power up the device, and then you have to program the device, and finally it gets into user mode where you can actually access and work with the device. The problem with that is that what if you're having an issue with your design during the reset process or initially when the design starts up, before you can come in here and manually start the logic analyzer itself with the run analysis button. Normally, there'd be no way to capture anything that's happening during that period of time. But with a power-up trigger, you can. So I'm going to switch back to instance 1 here, and I can right-click. And if I right-click, I see Enable Power-Up Trigger. Now, what that does is it creates, I call it a child instance. So it's a child instance of the main SignalTap instance here. And you'll also notice that some things turned blue in the settings here, okay? Let me change this. Oh, I don't want to use the state-based trigger flow. Let me turn off state-based trigger. Oh, I can't do that here. Let me switch back and turn that off so I can show you more stuff here. All right. Okay, so I've enabled the power-up trigger, and what that means is that I can define a separate but related trigger setup to the main trigger in the main SignalTap instance here. And anything that's highlighted in blue can be essentially different from the main, what we call the runtime trigger. So I could change the basic trigger conditions. So not letting me, oh, I have to right click the so I could just go in here and I could, make some changes here, and looking for these certain trigger conditions during that period of time before the logic analyzer starts, before I can manually start the logic analyzer. You'll notice that if I switch back to the main instance here, it's still back the way that it was. So the two instances are related, but different, okay? As a shortcut, I could make the power-up trigger look for the same setting. So if I say duplicate trigger here, oh wait, maybe I have to switch to this one first. Yeah, duplicate trigger. So that basically copies my trigger conditions from the main instance to the power-up trigger. But then again, I could just customize this however I want. So, but what happens is that once you enable a power-up trigger, you have to fully compile your design. You cannot get away with the ECO compile or anything else I've talked about for recompiling the design faster. You have to fully recompile your design because SignalTap becomes part of the initial power-up hardware for your design. Once the device is configured, the logic analyzer immediately starts running. And if the trigger occurs during that period of time, when you first come into the SignalTap file here and you click this button, if the power-up trigger occurred, you will get data on the data tab that's highlighted in blue. And the blue, again, is indicating that it is data that was captured as part of the power-up trigger. After you've worked with the power-up trigger data, you can continue working with the logic analyzer and running the standard runtime trigger, okay? The power-up trigger will not run anymore until you reprogram the device. So it's a one-time thing to capture these events that happen right when the device is programmed. Okay? That answer the question?
Yeah, yeah. I just add that we use that for PCI Express link training debugging. We use the transitional storage qualifier and the power-up trigger, so we could capture, as our PCI Express hard IP was going through link training, we could just watch the steps of link training by using both of those together.
Great, great.
Question.
Are there any other questions?
Yeah, so it just came in here now. So they quoted from the application note 922 that ECO compilation is not supported on ARIA 10. And the question was, is ECO compilation needed for rapid recompile?
So that goes back to what we were talking about before. I'm
Yeah.
not sure if that mention of it not being supported in ARIA 10, which again is total news to me, is related to this ECO compilation.
Right.
Because this is a newer feature and it's specifically for Signal Tap. So I have no idea if it's related. So that's something we need to find out.
They could like not support it for the ECO tool, but then
Yeah.
they may support it, because it's under the hood, for Signal Tap, because it's doing something under the hood that the user isn't doing. So that's what we have to confirm.
Exactly. Yes, exactly. So, but thank you for the reference.
So other question, debugging and time enclosure. Does adding debug nodes impact time enclosure? This is one that came in offline.
Okay. It can. So one of the things about debugging, anytime you add a wire stub, whether it's an additional FPGA internal routing wire or it's on a board that you're connecting to, you are affecting the wire in some way. It could affect signal integrity. It could affect timing. So Signal Tap certainly could have an effect, which is why usually when you're done debugging, you remove Signal Tap from your design. And the tool makes it easy to do that with just a checkbox that you turn off in Quartus to remove it, and then you just recompile your design. But it certainly can affect it, and it's something to be aware of. So was there more to the question than that, or?
No, I think that was all the question was.
Okay. Okay.
So one other ECO question: when was the ECO Signal Tap flow introduced?
That was introduced 21.3, I believe. Yeah, 21.3.
Okay. So that answers that question there. Communication channels, that's a good one. Communication, is the communication channel only JTAG, or are there other protocols that can be used?
Right now, it's just JTAG. It's using the same hardware connection that you'd use in the lab for programming the device with an SOF. It's only JTAG. I don't know if that is going to change at some point, if you'll have other options, but it's been JTAG for almost 20 years, so I don't know if that's going to change.
Yeah, maybe you have a really good reason to do that.
Yeah.
In line with that, can you talk about remote? Because you've done a lot of work with remote debugging with JTAG. Can you talk a little bit about what you could do there?
Sure. So remote debugging, that is a good question. Let's see, for that, let me switch to Quartus here. I'm going to open up the Quartus programmer. So for those that are not aware, Quartus does include remote debugging. The idea being that you on your computer are not sitting right in front of the FPGA device. The FPGA device is connected to another computer in another physical location. And that remote computer that you're connecting to that has the dev kit or whatever you're debugging doesn't have to have a full installation of the Quartus software. It just has to be running the Quartus programmer. And you can set up that remote machine as a JTAG server, okay? So it could be on your network, it could be even over the internet. You can configure and set up a JTAG server. And then you, sitting at your desk, can connect to that remote machine and work with JTAG tools like Signal Tap as if you are sitting right in front of it. We have this graphical interface built into the programmer for setting this up. There is also command line options for doing this, and it works with SSH So if you're using Secure Shell to connect remotely, the JTAG commands can be sent over that and then issued to your FPGA device to program it and to work with the dev kit. Marlon brought it up because in our training classes now, we do all of our training classes in the cloud. And so you've got a machine that's running in the cloud, and then you've got a development kit that's basically at our factory in San Jose. And so those machines in the cloud can connect remotely to JTAG server machines in San Jose and access those dev kits. So you could be anywhere on the planet, connect to a VM, a virtual machine in the cloud that's running Quartus, and then use remote JTAG debugging to connect to a development kit that could be at a third location on the planet in order to debug. So it's really quite versatile for remote debugging, and we use it for our training classes. So.
Thank you, Steve.
Sure. Anything else right now?
Yeah. Next, so pro versus standard. Like, what are the key differences between the two tools when it comes to SignalTap?
When it comes to SignalTap, differences between pro and standard. Oops. Okay. So let's see. What should I highlight here? So obviously I don't know why it's doing that, but obviously I am in pro right now. I've been showing pro. The short answer to the question is there's not much. All of the basic setup for adding nodes to the node list, setting up your basic trigger conditions, most of the options are all the same between pro and standard. I highlighted the big one earlier, the ECO compilation is only in pro. There's also a couple of other features that are in the slides that I can show real quick if we're running out of time, but that are pro specific. But all the basic functionality for SignalTap is identical between standard and pro. I can't think of any other big differences right now between the two that other than what I've got in my slides. So. Any other questions, Marlon?
Let me see. What's the other one that I have not asked yet? I'm kind of bouncing around these. Give me 1 second.
Okay. So we got about 10 minutes left. If you want to get those links in the chat.
Yes, I put the links in the chat already for all the documentation. Perfect. Now I'm putting the one for the survey.
The survey.
Good one. PR. How does SignalTap work with PR?
Oh my gosh, that for partial reconfiguration.
What are the special things you have to be aware of, or that you have to, not necessarily you have to go into all the details, but like, what are things you have to consider if you want to do SignalTap with PR?
Okay, rapid fire, because there's that is huge. But the main issue, so for those that don't know, partial reconfiguration is the idea of, you have your design running in hardware, and then you basically take out a block of your design and replace it with another block, another functional block, while the design is running, and then it continues to run. The main issues with partial reconfiguration and SignalTap is that when you do that exchange, when you pull out one block and replace it with something else, if SignalTap is inside that block that you pulled out, well, obviously you don't have access to SignalTap anymore. But also, if SignalTap is not in that block that you're exchanging, you have to make sure that SignalTap will still be able to connect to the signals in the new block the way that it was connected to the signals in the original block. And so we include special IP, bridge IP, to make that happen across the boundary between a PR partition, a part of the design that you can replace, and the rest of the design. But there's a lot more to that I just don't have time to cover in this session. So.
No, that's good. Just the mechanism, so that if they're looking at that, those are things they have to consider.
Yes. Any other questions, or should I take a look at some of the new features real quick at the end here, or what?
Yes, go ahead and take a look at some of the new features, the other new features. Oh, wait a minute, no, here's one. Just a very quick
Okay.
answer. Is SignalTap easy to use?
Is SignalTap easy to use?
Yes.
um,
I thought that was a good one.
That's a good one. That really depends. You know, again, I've been using it for almost 20 years, so it's pretty easy for me. I think, gosh, how can I answer? That's a tough question. It's easy to use once you know what the controls do. And unfortunately, the tool doesn't make it immediately obvious for that. Like, are you going to know right off the bat that you can double click here to add signals? There's just a number of indicators that are kind of, you know, not immediately obvious. Once you know the basics, though, it is easy to use and it's very flexible. So that's why we link you to documentation and training, so that if you have any questions about a certain part of the interface, those are all answered there. But yeah, that's a tough question.
Yeah,
For a
I thought that
brand
was
new
good.
user, for a brand, it's being diplomatic. For a brand new user, it's going to be a little tricky. But you know, I don't think it should take too long for people to get it if they just go through a little bit of training or documentation.
I kind of say there's like a basic use, like the standard basic use that everybody's going to have to do,
Yes,
no matter how
exactly.
they use
Yes.
the tool. And so
Hmm.
you learn that, and that's, like you said, it's not necessarily intuitive, but you learn those 5, 6 steps, and that's
Yep.
everybody does that. But then there's
Yep.
all this advanced stuff that you can do on top of that that
Exactly.
makes it seem more complicated than what it really,
Yes.
you know, is.
Yes. That's exactly the way that I organize my training on it. I have if you go through my e-learnings about it, I start with just the basics of exactly what you need to set up a trigger and be able to capture data immediately. And then if you want to learn more, you continue the training and you learn about all the additional features that you can use. So yeah, just
Okay,
you learn the
so
basics, get started there, and then go on.
lots of good questions popping in at the last minute. Okay,
Oh, okay.
so after compilation, some nodes appear to be red while others are black. What do the colors mean?
Okay, so black nodes are, as mentioned, pre-synthesis. So those are signals that you tapped directly from your HDL. Blue nodes are post-fit. Those are nodes that you tapped after the design has fully compiled and you're tapping from the post-fit netlist, meaning that when SignalTap connects to those, it's going to use available routing channels to make those connections. Red ones indicate that you've done something that has made it so that that signal is not available for some reason. Maybe you've changed, maybe it was tapped previously and you changed the design, or you recompiled and it got optimized away. That's why I didn't get a chance to talk about it. The preserve for debug option in Pro guarantees that nodes are preserved through the whole compilation flow, so you will not lose nodes in that way. So, but that's what the red means.
Good. Next, multiple clock domains in SignalTap. If you want to tap signals from 2 separate clock domains, is there anything special you need to do?
The only thing you can do in that case is have multiple instances, because each instance only uses a single sampling clock. So if you're tapping signals for a particular clock domain, you would usually use that clock as the sampling clock. But yeah, the only thing that you can do if you want to look at signals in different clock domains with the appropriate amount of sampling data is to create a separate instance for each one.
There's clock domain crossing on the boundary into SignalTap on the data channels, correct? So if you're using a single sampling clock and you're sampling signals from different clock domains, they will get sampled, but
they will get, yes, they will get sampled, but if you're using a different clock than the clock domain
no
where that signal lives, yeah, there's no correlation. So you could be undersampling and not see everything about that signal if you are using a slower sampling clock than the clock domain that the signal is coming from.
Okay, that's the other question. And one final question here. Can SignalTap insertion be driven by TickleScript?
insertion into your Quartus project.
That's not specific. Oh, here he comes. He's responding again.
It is just a QSF setting, so you can enable it through Tcl scripting.
Insertion into a compiled routed design.
You still have to configure the signal tap file,
right.
but you can enable or
right.
disable it through Tcl scripting. Because it's just an assignment that goes in the QSF. So I don't know if that's what they're looking for, but
yeah, I think so. Can you be driven by Tcl? Yeah, the setup of the STP file is still GUI driven.
Yeah, you still got to do that.
It's an XML file, but you don't want to be digging in there trying to do stuff.
Yeah, exactly. Yeah, I mean, some people like to do that, but no, I just use the GUI. It's going to just make your life so much easier.
Right, but adding it to a design and removing it from a design, that's QSF driven. So a Tcl command could do that.
Yep. I think we're out of time, Marlon.
I think that's takes us to the top of the hour.
Okay.
Any final things before we end?
Yeah, so just I'm just going to mention these. They're in my training. If you attend tomorrow, you can learn more about them. Just I talked about preserving for debug. In the Pro Edition, there's also the ability to tap simulation aware nodes. And what this does is it creates a special simulation script that when you run it will show you signals that you have manually tapped in hardware, but also can infer the functionality of additional signals in the cone of logic for these simulation aware signals. And so these additional signals will show up in your simulations. You get more detail beyond what you've tapped. So you can check that out, and also in the links that Marlon put in the chat, there's also a link to a demo of this feature as well. So yeah, if Marlon will put the resource links as well as the survey link. Was there anything else, Marlon?
That is all.
Okay, so thank you everybody for attending our training session. As I mentioned, there is a survey link that has been placed in the chat. It's a really quick survey. It's lots of multiple choice that makes it really easy. So we'd love to hear from you. Let us know what you think. If there's any other topics you think should be in our Ask an Expert session. And then when you, after the fact in a day or two, you'll get a link that will also include that survey again, as well as a link to the YouTube recording once that goes up. Okay. So thank you all for attending, and we will see you at the next one.
Thank you, everyone. Bye.